So sample space is the set of all possible outcomes. Let's say, for example, tossing a coin is an event. So sample space is denoted by S, and this is here we will write all the possible outcomes. So if you are tossing 2 points कर लो 1 के बजाय, for tossing dice कर लो 2 points कर लो, कुछ भी कर लो, tossing 2 coins. So sample space क्या होगी? Head, first head, second head, first head, second tail, first tail, second head, first tail, second tail, 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 head, head, 2 raised to power 2. So 4. There are 4 possible outcomes. Okay. And rolling of 2 dice. Then 36 outcomes will come. So here in coin 2 raised to power n formula, here we use 6 raised to power n. So these are the things that we already covered in class 11. 1, 1, 2, 1, up to 2, 6, like this, 1, 6. So here up to 6, 1 to 6, 6. So there are 36 outcomes here. So NS, what is NS? We are writing number of outcomes by using NS is equal to here 4, here NS is equal to 36. And if the event is finding, suppose doublets, so doublets, finding doublets, event is finding doublets. So doublets, that means this event, if you want to write the event, it will have the outcomes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, sorry, 4, 4, 5, 5, 6, 6. So this is the total outcomes. So number of outcomes in sample space in event is equal to number of favorable outcomes is 6. So probability is equal to number of favorable outcomes upon total number of possible outcomes. Okay. So this will be equal to 6 by 36. That is 1 by 6. So this was a simple probability that we already did in class 11. And if you remember it, then AND means whenever AND is coming in any event, finding 2 events A and B. So we used to have multiplication. And when OR is coming, we used to have plus. So that are the basics. We are not going in detail in that basics. Okay. Because now we have to start the conditional probability. In our course, we have conditional probability. Conditional probability means some conditions are applied. For example, out of the 52 cards, we are taking out one ace. First, we are taking one ace. Okay. So then probability will be equal to 4 by 52, simple probability. Okay. The probability of one ace, first ace, you can say first ace is equal to 4 by 52. And then the question is, first ace is already taken. Then find the probability of taking the second ace. Second ace. So for finding the second ace, the first ace is already we have taken, and then without replacement. This is without replacement. I'll tell you later on without with replacement. That also we study. Without replacement means we are not putting back the card selected. So now this out of four, one card has been taken, that is an AC. Yes, that is an ace. So three are left, and here total will become 51. So this is the condition. So condition for the second event, the condition has been applied. So this type of the events are called, this type of probability is called conditional probability. So some conditions are applied here. On that basis, we will find the probability. And the first exercise, our CRT is based on conditional probability only. So we are not going in detail of the uh, basics, directly starting the conditional probability. So A and B are the two events associated with. So this type of probability will be conditional probability. One more thing, when we go ahead, so we will find one, you know, that multiplication theorem. So in multiplication theorem, do two events are multiplied when there is an and between them. But the problem is we have to check whether it is the dependent events or independent events. So if we are talking about the dependent events, that means we are taking out a card or a ball from a bag without replacement. Without replacement. And if it is independent event, then it is with replacement. It is with replacement. So without replacement, that I just gave you an example. We can suppose one king, we have to find out the first king from two kings, taking out or selecting two kings or two queens. Take two queens we have to select, and without replacement. Okay, the probability of two queens, way out of 52 cards. So selecting of two queens or getting the probability of two queens is equal to, first queen will be selected out of four queens, 4 by 52. And because first event has done and दूसरे event पे जा रहा है, the and word is we are using, so multiplication will come, and the card which is selected is not being placed back. So that means without replacement, तो एक card जो निकाला वो वापस नहीं रखना है. So therefore the card was selected was queen. So out of 4, now one queen has been selected, so 3 queens are left, and one card out of total card, one card is taken out, so 51. So this will be the answer. But if it is with replacement, the same question is asked, find the probability of taking out two queens from a well shuffled pack of 52 cards. So in that case, probability of these two queens will be first we will select out of 4 queens, 1 queen by 4 ways, and total number of ways are 52, and then again we have to put it back in the pack, well shuffled pack, and then well shuffle it, and then again take out. Then we can again select 4 out of 52. So this is the main difference that you will find in the coming questions. But now before that, it will come later on. But now we are starting that conditional probability. We are going to start the conditional probability. So in conditional probability, if A and B, the main thing is we have to find, here also you can see that one coin has been taken out, means first event has been happened, then we are finding the second coin. So in these questions, the main thing is first event will occur. So how we will write, if A and B, if A and yes, someone is writing some chat. Can both the coin cards be the same for independent? Yes, that's why we are keeping can be. It can be the same card. Randomly we are selecting. Second time the same coin can come. A and B are conditional probability. A and B are two events. In probability, you have to remember or you have to understand better about the probability, because the calculation part is very easy. Only you have to take care of what are the conditions given, how to do it. So if A and B are two events and they are associated to associated with same sample space, means one sample space. From a sample space, we are taking two events from same sample space of a random experiment. I'll explain it rather than writing the definitions. I'll explain it. You can see in your textbooks. A and B are two events. A and B are two events of a sample space, means same sample space. Okay, in a random experiment. Then, so as I told you in the conditional probability, then the conditional probability is the event A given that B has occurred. Probability of A means B has already occurred and find the probability of A. So conditional probability or probability of the event A when or given that A when B has already occurred, when B has already occurred, it is written by probability of A stroke B, A stroke B is the probability of A when probability of A event when B has already occurred. So B has occurred, so it will be written after the stroke and is given by, so we used to write like this, probability of A stroke B when probability of A, B has already occurred. It will be equal to the probability of A intersection B divided by the probability of B. So the number which comes after the event which come after the stroke will be written in the denominator. And provided obviously the probability of B should not be equal to, this is provided probability of B should not be equal to 0. Okay. Similarly, if we have to find the probability of B when A has already occurred, then it will be equal to probability of A intersection B divided by probability of A. So in the question, you can easily recognize that the probability of which event has been already occurred. So this you can see from the question, you can easily recognize. There are some properties, then we will see the method, we will do the exercise. There are some properties of this conditional probability. Properties of conditional probability. First one, A and B are the events of the sample space that I'm not writing again and again, you know. If you have to find a probability of a sample space and one of the event of the sample space has already occurred, that will be equal to probability of that event when A has occurred, that is equal to 1. So always it will come 1. And second condition, if A and B, if A and B are any two events of sample space, any two events of a sample space first property is, if we have to find the probability of sample space or the same, if A and B are same, you can say A and B are same, then probability of A when A has already occurred will be equal to 1, obviously. Or probability of the sample space when one of them is already occurred. Okay. So the A and B are two events of a sample space S. These are the two events of the sample space, and there is a C. C is another event. C is an event. The third event C of S such that the third event should not be equal to 0. Then we can find the probability of A union B, and that previous year's formula is there. We will use in between maybe. Here also we are using the same formula, A union B, PA plus PB minus PA union PA intersection B. So similarly here, probability of A union B when C has occurred, this is you can write in the stroke, or we can write like this also. So here This is same as stroke. If we are writing A upon B, this is same in writing A stroke B. Actually, stroke we use, not upon, but here they are using in textbooks also. The probability of A union B when C has already occurred. So stroke, use stroke, I think that. Has already occurred will be equal to, for the third event, probability of A when C has occurred plus probability of B, C has already occurred, minus probability of A intersection B, intersection, when here union, it will come intersection when C has already occurred. So this is the same formula that we did. And you know that if A and B are disjoint, A intersection B, if A and B, that we did in class 11th, if A and B are disjoint events, disjoint events, then you know the A intersection B will be 0, so this will become 0. Only this part is left, probability of A union B when C has already occurred is equal to probability of A C occurred, probability of B when C has already occurred. This we will find. And the third property also, just you remember these properties, whenever it will come, first we will do the question, then you will understand better about it. So A complement, probability of A complement when B has already occurred will be equal to 1 minus probability of A when B has occurred. So this is just like probability of complement events. Okay. Now method to solve problem based on conditional probability. How to solve? But just you adhere to this method, you can do all the questions of this first exercise. Our method is number one. First, we will write the sample space. Write last property when A and B are disjoint events. And that was, yeah, you are asking last property. It is just like A dash. You have seen in class 11, probability of a complement event of not A is equal to probability of A. Similarly, here, probability of A dash when B has occurred will be equal to 1 minus probability of A when B has occurred. Same thing, the same property. This is the fourth property. Okay.
Mm.
So method is just you have to go through this method. First, you will write the sample space. Here you have to write the sample space. Method of conditional probability. Conditional probability problems. Write the sample space that I showed you in the beginning, how to write the sample space. Write the sample space for given experiment. Okay. Then second, also you have to recognize A and B events. Okay. Means assume, you can assume the A and B events. One is already occurred, one we have to find, so that you can assume the given events, because in question sometimes not given A, B. So assume the given events as A and B, okay, which are associated with this sample space. Second, find the probability of the event. First you can find, or this can be changed, no problem. Find the probability of the event. It may be A or B, which is already occurred, which is already occurred, okay. And then find probability of A intersection B, common event, okay. And last one, if you have to find the probability of B has occurred, probability of A, B has occurred, you will use this formula, probability of A intersection B upon probability of B, or if it is A has already occurred, whatever occurred already will come after the stroke or in the denominator in the formula, probability of A intersection B divided by probability of B, okay.